always nice to learn stuff that we already know, and we already know how to graph systems of inequalities, but we're going to just go over it. So what we're doing, well, first of all, we got to remember what an inequality is, right? Inequality is greater than or less than, right? And do you remember what kind of line we have with greater than or less than? Is it a solid line or a dotted line? Right, it's a dotted line, right? And then if it's greater than or equal to or less than or equal to, then we have a solid line. So here, if y is greater than negative x plus 1, I've got a y-intercept of 1, and then down 1 over 1. So here we go. Oops, and see, I already made that mistake. It's so easy to just make it solid when it should be dotted. So I'm going to go back and make that dotted. And how do I know which way to shade? Well, that depends on that sign as well. If it's solved for y greater than or equal to, we shade above, and then less than or equal to, we shade below. So that is a greater than, so that's going to be shaded above. And I just do kind of a light shading, right? If I look at the next one here, I've got to first solve that for y. So I'm going to throw that up here. Negative 2y is less than negative 5x plus 6. But what happens when I divide by a negative? All right, when you divide by a negative, you flip the sign. So it's going to become greater than 5/2 x plus 3. So that you got to really watch for. So then up 5, I'm going to go actually down 5, 2, 3, 4, 5, back 3. Same thing, right? And that was solid or dotted line again. And then greater than there is shaded above. So it's going to be like shaded above. And sometimes I like to even go back with another color and kind of highlight the double shaded area. So it would be the 2 dotted lines and right there, right? And this should be like, oh yeah, I remember this, right? Y is greater than x plus 2, up 1 over 1, again a dotted line, and that's shaded above. And then y is less than or equal to negative 2x minus 1, so from there down 2 over 1, down 2 over 1, and that's solid. And that's less than or equal to, so that's shaded below. Oops. And all you really need to show me is the double shaded area. The graph is your solution. And that's it. So now what we're going to do is do the same thing, but we're going to find the vertices of the polygon form. So this is going to set us up for our inequality story problems that we do next. So here I really like this one because it reinforces those two are horizontal lines, and then x between 2 and 4 are vertical lines. And with all those inequalities, we're just going to get this little square right here. And then when it says the vertices of the polygon formed, it just means the corners of the square. So the corners would be 2, 1, 2, 3, 4, 1, 4, 3. That's all. Similarly over here, the y is between 0 and 3. So horizontal line at 0, horizontal line at 3. The x is between 0 and 4. I'm just going to do that in the same color there. So I've got that rectangle. And then I'm going to come in here with y is less than or equal to negative x plus 4. So that's this line here. Right? So this is like a trapezoid shape here. And again, it looks like I've got 4 corners, one of which is 0, 0. Looks like 0, 3, looks like 1, 3, and then 4, 0 for these 4 corners. And we're going to use that skill with our story problems that we do next. Last one, kind of repetitive here. We probably don't even need to do it, but we'll just do it. Y is between 0 and 3. X is between 0 and 4. And then if I solve this one here, what do I have? 6y is less than or equal to negative 5x plus 30. So y is less than or equal to negative 5, 6x plus 5. So down 5 over 6. Now this one actually might not come out to be a nice point. I got to think about that. Right, so right off the bat you kind of see your easy points to find for your corners. 0, 0, 0, 3. It looks like 4, 0. But what about these 2 corners? Right? Doesn't happen often, and I'm just going to show it, but where you can solve it by hand. So like, let's say if I wanted to find this corner right there, I'm looking at where the line 5x plus 6y equals 30, because that's my border line, crosses the horizontal line of y equals 3. So I can solve that by substitution. 5x plus 18 equals 30, so 5x is equal to 12, and so it's a good thing I solved it because it does not come out even. So that ordered pair for that corner is 12/5, comma 3. Similarly, if I want to find this point right here, right, this other point right there, that's again the line 5x plus 6y equals 30, but now it's crossing our vertical line x equals 4. So 20 plus 6y equals 30, or 6y is 10, or y is 5/3. So that ordered pair there is 4, comma 5/3. So it won't always come out nice. Sometimes you might have to solve a system to find the corners in our graphing of systems of inequalities.